Okay, welcome back guys. In today's video we're going to talk about prime factorisation, or sometimes this can be called prime decomposition. And we're going to be working a lot with prime numbers, which are, as you will recall, numbers that have only two factors, so themselves and one. Prime numbers are in a way sort of foundations, the building blocks, the atoms of integers and number theory, okay? So they're quite important. You can use them to do a lot of different things, but today we're going to be looking at how they work with prime factorisation. So two factors themselves and one, for instance, 7 has only factors 7 times 1. Right, the other type of numbers that we deal with are composite numbers, which are numbers that have more than two factors. For instance, 6 has factors 2 times 3 and 1 times 6. So it has 4 factors. That being more than 2 makes it a composite number. Now, the important thing is that composite numbers can be reduced to the product of a set of prime numbers. So a unique set of prime numbers and product of, remember that means things are multiplied together. Okay, so we multiply together a bunch of prime numbers, we can arrive at a composite number. So the way that we do that, to get that set of prime factors, is using factor trees. It's probably the easiest way. So we're going to do a couple of factor trees here for 24, and especially if it's an even number, the easiest way to go about it is just divide by 2. And so 24 divided by 2 is 12. Now obviously it's very good if you know your times tables for factor trees. That goes really for everything, but it's especially good for factor trees. So in 12, so you look at this next row, 2 is a prime number, so you stop. 12 is not a prime, so we can keep going. 2 times 6, and 6 can go to 2 times 3. Okay, now you can put the little times signs in here if you want, if that helps. You don't really need to. I wouldn't mind if you drew a line down, and you essentially want to represent all of these prime factors down the bottom here. So we'll have 24 is 2 times 2 times 2 times 3, which is equal to 2 to the power of 3 times 3. Okay? 2 cubed is 8 times 3 is 24, works. So that is the prime factorisation of 24. Okay? Right, let's have a look at the factor tree for 36. Again, 36 is a even number, so it's easy to go with the 2 times 18. 2 stays. 18 is 2 times 9. 9 is 3 times 3. And that means our prime factorisation for 36 will be 2 times 2 times 3 times 3. Okay? You have to put all the primes into this prime factorisation. It's always nice if you shorten it using index notation. So 2 times 2 is 2 squared times 3 squared. Now, just to show you, each composite number has a unique prime factorisation. So no matter what you choose for your factor tree, it will always come up the same way. So 36 is also 6 times 6, which is 2 times 3 and 2 times 3. So we have 2 times 3 times 2 times 3, which is the same as 2 times 2 times 3 times 3, etc. So no matter how you go about it, as long as you're doing your factoring correctly, it will always work. Now, we do actually use these, and it's quite powerful, because one of the things that we've been doing this term is, or will be doing, is working with highest common factors. Now, sometimes finding highest common factors isn't the easiest thing to do, or is sometimes a little laborious. So there's a little trick using these factor trees and prime compositions, is that the highest common factor of two numbers is the product of the common prime factors raised to their lowest power. So let's do the highest common factor of 24 and 36. Now, just up here before, I showed you that 24 is equal to 2 to the power of 3 times 3, and 36 is equal to 2 squared times 3 squared. Right, so we're looking for the product of the common prime factors raised to their lowest power. So we have 2 as a prime factor. So both of them have 2's, but one was raised to the power of 3, one's raised to the power of 2. So the lowest power is the 2 to the power of 2. So the highest common factor will be 2 to the power of 2 times, they both have a 3, one's to the power of 2, one's to the power of 1. So we use this one, the power of 1, because it's the lowest. So 2 to the power of 2 times 3 is equal to 4 times 3, which is 12, which is the highest common factor of 24 and 36. So it's a really quick way of doing it rather than having to list out all the factors and that kind of thing. Right, if you're good at your prime decompositions. Okay, lowest common multiple. The lowest common multiple of two numbers is the product of all the prime factors raised to their highest powers. So let's have a look at our LCM of 24 and 36. So 24 was 2 cubed times 3, and 36 was 2 squared times 3 squared, and that means we have our LCM is all the factors. So we have a 2 and a 3, that's it. So we have a 2 times 3, and we have to raise them to the highest powers. Our 2 highest power is a 3, our 3 highest power is a 2. So 2 cubed times 3 squared, 2 cubed is 8, times 3 squared is 9, 9 eighths is 72. So 72 is the lowest common multiple of 24 and 36. 3 24s is 72, 2 36s are 72. Okay, so I want you to be ready to have a shot at a bunch of that stuff in class. Essentially, you just need to be getting very good, very fluent at your prime decompositions. Very important to be able to do that. It'll help you to understand so much more about the numbers, and I hope you've enjoyed this video. Please come with any extra questions that you might have. Thank you.